Here we're going to learn about yet another way to solve a system of equations. So this one's called the substitution method. So far we've learned that a system is just more than one equation. And when we talk about a solution to a system of equations, we're talking about a x and a y that we can plug into both equations and make them true. It's a set of coordinates, an ordered pair, that makes both equations true. And we've figured out how to find that in two different ways. We can use elimination, or we can use graphing. So graphing is the visual one. You can just see it directly on the coordinate plane. That is the solution. The points where they intersect is the solution to the system of equations. Using elimination, we find a value for x and we find a value for y. That also represents that same thing. It's just an ordered pair where these two lines hit each other. We're going to talk about a third way today, which is called substitution. This can be more intuitive sometimes. Actually, it really just depends on the situation when you want to use it. The whole idea here is that you're solving for one variable, you have an expression for that variable, and you're going to take that entire expression and substitute it into the other equation for that variable. And we've actually talked about this before when we're solving equations. Now we're going to be talking about two full linear equations. And sometimes this makes sense to do, sometimes it makes more sense to do elimination. If they're in slope-intercept form, it definitely makes the most sense to just graph it, have the calculator find the intersection for you. Really depends on what the problem looks like beforehand. So we're going to solve one of the equations for either one of its variables. You can pick either equation, and you can pick either variable. Then we're going to do the substitution part of this. We're going to substitute the expression from step 1 into the other equation and solve for really the opposite variable. Then we're going to substitute that value in. So at this point, we'll have something like x equals 10. We'll take that value, substitute it back into either of the original equations, and solve for the opposite. This helps us solve for whatever the y is. We're going to write that as an ordered pair. And we can always check our solution by plugging it into both of the two equations. It should make both equations true. And if you want to, just as a backup, you can always use a different method and make sure that it works with that method also. It makes the most sense to use that with graphing so that you can see the ordered pair that you found from that x and y combination. Alright, so I'm looking at that first problem and I'm trying to decide what is the easiest variable to solve for. So I see that in my first equation I have coefficients, I have a 3 and a 5 attached to my variables. That means it's going to take an extra step to solve for those. That means I'm going to have to divide that coefficient away. So instead of doing that, I'm going to use the second one, and I'm going to solve for y. It's already by itself, so I know I'm not going to need to divide anything. I'm just going to need to subtract the 6x from both sides. I'm going to need to subtract this to get it onto the other side. That gives me y by itself. It's canceled out, and that gives me that y is negative 10 minus 6x. That entire expression is y. These two are the exact same thing. So I can take this expression and put it anytime I see y in the first equation. I can put it in place of that y in my first one. So I'm going to rewrite that 3x plus 5 times y, but instead of y there, I'm going to substitute this whole expression in. Negative 10 minus 6x equals still negative 23 on that side. Y and that expression are the same thing, so I'm really just replacing the y with that expression. Now I have an equation that only has x's in it. So I can actually solve that equation for x. I'm going to distribute first. 5 times negative 10, 5 times negative 6. gives me 3x minus 50 minus 30x. I'm going to combine like terms next. 3 minus 30x is negative 27x. Minus 50 equals negative 23. Now I have a two-step equation. I'm going to add the 50 over. That gives me negative 27x equals 27. And then I divide by negative 27. That gives me that x is negative 1. So I have my x value. I still need my y value, so I'm going to take that negative 1 and plug it back in for either equation. It really doesn't matter which of these two equations I pick. I'm going to pick the bottom one. So I'm going to plug in color 6 times negative 1 plus y equals negative 10. I have my x value that I can plug in. It's the exact same substitution step, except now it's a number instead of an expression like it was before. And now I'm just going to solve this equation. I get negative 6 plus y equals negative 10, and then I add 6 to both sides. That gives me y is negative 4. So my ordered pair is negative 1, negative 4. That's the x and the y that makes both of these equations true, and it's the ordered pair where these two lines meet on the coordinate plane. Those are the exact same thing. All right, on my second one, y is already by itself, so I already have an expression for y. I'm going to take this and put it right in place of that y. I'm going to substitute that whole expression, x plus 3, in place of y. I have 5x plus 3 times the entire thing, x plus 3, equals negative 7. Now I'm just going to solve that equation for x. I just have one variable now. So I'm going to distribute first. That gives me 5x plus 3x plus 9 equals negative 7. We combine like terms. And 8x plus 9 equals negative 7. And then 8x equals negative 16. I just subtracted 9 from both sides. Last step is just dividing by that 8. That gives me that x is negative 2. So I have my x value. I still need my y value. I'm going to plug that back in. I'm going to use the first equation because that is so simple. I'm going to take that number and just plug it in for that x value. So y is negative 2 plus 3, so y is 1. So my ordered pair is negative 2, 1, that's the x and the y that make both of these two equations true, and it's where they meet on the coordinate plane. So we're just going to do a few more examples dealing with some special cases and some word problems. So on this first one, again, you want to look for the easiest variable to solve for. That y on the bottom is already by itself, so all we will need to do is subtract the 3x from both sides. So we got y equals 1/3 minus 3x. You can change that 1/3 into a decimal, but when you type it in, it needs to be a repeating 3 there. Don't just type that in as 0.3. Don't just stop after a couple 3's. You need to have a repeating decimal there. So I'm going to take that whole thing and substitute it in place of y. That gives me 9x minus 7 times 1/3 minus 3x equals 2/3. I'm going to distribute that negative 7. 9x minus, I'm going to keep it as a fraction, 7/3 plus 21x equals 2/3. Now I have to combine like terms. That gives me 30x minus 7/3 equals 2/3. And now I can add that 7/3 to both sides. That gives me 30x equals 9/3. Or 30x equals 3. That means that x is 1/10. You can also write that as a decimal, it's just 0.1 if you want. Now I'm going to take that x value and plug it back in. I'm actually going to keep it as, actually let's see it as a decimal. I think it might be easier to see it as a decimal. You can write it as a decimal, you can write it as a fraction, really whatever you're more comfortable with. I'm going to write it as a decimal into the second equation. So 3 times, I found my x value. I'm going to change the color of that just so we can see a little easier. Well, let's go with that. So 3 times, I'm going to change that into a decimal, that's 0.1. plus y equals 1/3 as a decimal is 0.3 repeating. So I'm going to multiply 3 times 0.1, that's 0.3, plus y equals 0.3 repeating. And I'm going to subtract 0.3 from both sides. All right, so I'm going to do minus 0.3, minus 0.3. And if you can imagine this is 0.3000 going on forever. This is 333 going on forever. When I subtract those, if I subtract straight down, that's nothing. This is going to cancel out. This 3 cancels out. The rest of these 3's going on forever are still there. So this is going to be y equals 0.0333 repeating. We still have all of these 3's going on forever after that first decimal place cancels out. So that's 0.03 repeating. I'm going to write this as a fraction. I just happen to know that fraction. If you want to write it as a decimal, that's perfectly okay when you write the ordered pair. I'm going to change it to a fraction because I already know the x is 1/10. This happens to be 1/30. If you want to write them as fractions, decimals, it really doesn't make a difference. It's got to be accurate though, so if you're going to work with it as a decimal, you need to make sure that you keep all your repeating 3's there. On the next one, I have coefficients on my x and my y on top. I guess I could just divide by 3 on the bottom one. So I'm going to solve for y here. I'm going to divide by 3. So I'm splitting this into 2 division problems. I'm splitting that into 2 divided by 3 and negative x divided by 3. So y equals 2/3 minus x over 3. I'm going to take that whole expression, substitute it in place of y. So I got 2x still, plus 6 times y, which is now 2/3 minus x over 3. That equals 4. I'm not going to write that part because I don't have room, but I'm just going to simplify this a little bit by distributing. 6 times both of those terms, 2x plus 4 minus 6x over 3. That equals 4. That second x term, that 6x over 3, we can divide that. Really, we could just simplify that. That's 6 over 3, or minus, that changes into 2x. And something kind of special is going to happen here. We have 2x minus 2x, that's just 0. So we have 4 equals 4. That's a true statement. So we know that anything that we plug in for x is going to make these equations true. We have an infinite number of solutions. These are the exact same equation. They're really the exact same line. They overlap at every single point, so they have an infinite number of solutions. And you can see that probably easier from changing this into standard form. I see that, like, I add this x over on both sides. That gives me x plus 3y equals 2. I can see that if I multiply this entire equation times 2, it's the exact same equation as the first one. So sometimes it might be more practical to use elimination. Sometimes it might be easier to use substitution like we did here. But this one, I see that clearly turning into the first equation, which means that elimination actually might be easier to use here. Number 3, my y is already solved for, so I don't really need to do too much work there. I'm just going to take that and put it in place of the y in the second equation. I got negative 10x minus 5 times 18 minus 2x equals negative 4. And now I have to distribute a negative 5, so that's 10x, sorry, negative 10x. That's minus 90 plus 10x equals negative 4. Again, that same special thing happens here. We have a 10x and a negative 10x canceling out just like we had before. One thing is different about this time. We have 2 different constants. Now we have negative 90 equals negative 4. That's not true. So there is nothing that we could plug into this to make these equations meet. These equations never meet because they're parallel, and that means they have no solution. There is no point of intersection between those two lines. And we can tell that from this last line. When you get two constants by themselves and they're not equal to each other, that means there is no solution to that equation. Number 4, we have a word problem that we have to set up into a system of equations. So I'm just going to help you set it up, and then you can probably solve it on your own from there. So a store is selling DVDs for $10.50 and $8.50. You buy 10 DVDs and spend a total of $93. How many DVDs did you buy that cost $10.50? So my first step is always just labeling my variables, thinking about what I'm actually trying to find, trying to figure out the DVDs that I bought that cost that much. The other thing that we don't really know here is how many DVDs cost that much. So I'm going to call this one my X, I'm going to call that one my Y. So they're giving us the price, but they're not telling us how many of those. And I know that the total price is $93, $10.50 for all of these kinds of DVDs, plus $8.50 for each of these kinds of DVDs, adds up to a total of $93. This whole equation is talking about the cost. This is talking about the number of that type of DVD. This is talking about the number of that type of DVD, but the entire equation is talking about the cost. I know my X and my Y are just talking about how many of these I have. So those two put together is the 10. It's still talking about the number of DVDs of each kind, but we're not talking about the cost anymore. Now we're just talking about how many of them we actually have. So the X plus the Y, those two types put together is 10. And I'm going to come back to number 5. I just feel like doing that word problem since we just did one. Jordan is selling tickets for the school play. On the first day of ticket sales, he sells 3 child tickets and 1 adult ticket for a total of $38. Then he sold $52 in tickets by selling 3 child tickets and 2 adult tickets. What's the price of the adult ticket and the child ticket? So we're talking about children's tickets and adult tickets adding up to different amounts on different days. So those are my 2 variables. I'm going to call X my children's tickets. I'm going to call Y my adult tickets. Doesn't matter. You could switch those if you really wanted to. I'm just labeling them as X and Y just because I feel like it like that. I could switch those variables. Those 2 have to be my variables though, because that's what I don't know yet. I don't know the number of tickets for either children or adults. So I have 3 children's tickets on the first day. So 3 times however much it costs for a child's ticket. Excuse me, I just misspoke. I said that we don't know the number of tickets. We do know the number. We don't know the cost. That's what we're trying to find. We're trying to find how much this costs and how much that costs. We know that we sold 3 of the children's tickets on the first day, and we sold 1 adult ticket. And that adds up to a total of 38. The second one, we know that we sold, again, 3 children's, and we sold now 2 adult tickets. And that added up to a total of $52. So you can see that those are both in standard form already. I would be using elimination here. I would not be using substitution. I do want you to practice with substitution. So I'm actually going to solve the first one for Y because that's already pretty much by itself. So you get Y equals 38 minus 3x. I think you can probably finish it from there. We're going to take that whole expression and substitute it in for Y in the second equation and then solve for x. Again, when you see a word problem like this, the strategy that you use to solve it is completely up to you. When you see both of them in standard form, especially when you see the same coefficient on the x's like that, I would be using elimination. You can also just use logic to solve this problem. If you really think about it, this is just increasing by 1 adult ticket. We just sold 1 more adult ticket, so the difference in price there is coming from that extra 1 adult ticket. That's an extra $14. You should be getting 14 for your Y. When you solve for Y eventually, you should be getting 14 for the price of an adult ticket. All right, I'm going to go back to number 5. Let's solve for y there, because y is almost by itself already. We're going to divide by -1 into everything. It's really just going to change the sign of everything, so that gives us y equals -2x plus 16. Now we have an expression for y. We're going to take that whole thing and put it into the first equation. So 5 times -2x plus 16 minus 20 equals -4x. You see that the appeal of using substitution is that it doesn't matter what form the equations are. We don't need to get things into standard form. As long as you can get one variable by itself, you can substitute that whole thing into the other equation. I'm going to distribute first. That gives me -10x and 80. -10x and plus 80 minus 20 equals -4x. I'm going to combine my terms on the left side. -10x plus 60 excuse me, equals -4x. And I'm going to combine my terms to one side. I'm going to add 10x to both sides. That gives me 60 equals 6x. And my last step is dividing by that 6. So x is 10. I have my value for x. Now I'm going to solve for y. I'm going to plug it into that second equation. That looks a little bit easier. So I have -y equals 2 times 10. It's going to give me 20. Minus 16 is 4. That -y equals 4. And there's really a negative sign or a -1 in front of that y. So I'm going to divide by -1 on both sides. That gives me that y is -4. And so my ordered pair is 10, -4. That's the point that makes both those equations true, and it's the point where these two lines meet on the coordinate plane.